Hello guys, this is Optometry Akhilesh Kumar. This time Optometry Academy welcomes you all with a new video on AC by A ratio. In this video I am going to explain you about what is AC by A ratio, examining methods, indications of measurement of AC by A ratio. So let's start the video after this short intro. What is AC by A ratio? AC by A ratio is a measurement of changes in accommodative convergence in prism diopters induced when the patient exerts or relaxes one diopter of accommodation. Changes in the accommodation are either evoked by placing plus lens which relaxes accommodation or by minus which activates accommodation, or when a person fixates at a near target. Required instruments: Snellen's distance vision chart, near accommodative target, prism bar, scale, occluder, trial set with trial frame. Examining methods. There are several methods used clinically to determine the AC by A ratio: heterophoria method, gradient method, graphic method, and fixation disparity method. But in this video I am going to explain you about heterophoria method and gradient method. These two methods are mostly used in measuring the AC by A ratio. Heterophoria method. Heterophoria method is based on the difference in deviation between distance phoria and near phoria, and this method takes account of patient's interpupillary distance (IPD), which is an important factor if accommodative changes are induced by placing the target at near. As convergence required for a patient with a larger IPD is more compared to a patient with a small IPD when the target is placed at 40 cm far away from the eyes. AC by A ratio is determined by using the formula where IPD is intrapupillary distance in centimeters, NFD is near fixation distance in meters, HN is heterophoria at near in prism diopters, HD is heterophoria at distance in prism diopters. The sign of isophoria is plus, and for exophoria it is minus. Let us understand the whole procedure of heterophoria method with the help of an example. First of all, measure the patient's binocular interpupillary distance. In this patient it is 70 mm. So our IPD value is 70 mm or 7 cm. Make sure the patient is wearing their appropriate correction. Ask the patient to look at a 6 meter far away target and measure the patient's distance phoria. Here the distance phoria is 2 prism diopters, isophoria. Hold a near target at 40 cm. This is our near fixation NFD, which is 40 cm or 0.4 meter. Then ask the patient to look at the near target and measure the patient near phoria. Here the near deviation is 6 prism diopters, isophoria. After the examination we got the following values: interpupillary distance IPD 7 cm, near fixation distance NFD 0.4 meter, near phoria HN 6 prism diopter, isophoria, distance phoria HD 2 prism diopters, isophoria. Put these values in the given formula. The AC by A ratio in this example is 8.6:1. Gradient method. The gradient AC by A measures the amount of convergence generated by a diopter of accommodative effort. This is done at a fixed distance, whether for distance at 6 meter with concave lenses to stimulate accommodation, or at 33 centimeter with convex lenses to relax accommodation. The IPD is not important as the divergence is measured at the same fixation distance. Using concave lenses for 6 meter at distance, the patient is made to wear his proper refractive correction and the deviation is measured at 6 meter with Snellen's chart with PBCT. Here in this patient, the distance deviation is 8 prism diopter esophoria. This gives our baseline phoria. Now add minus lens, -1 or -2 or -3, any of them in front of eye binocularly. Here I am placing -2 diopter lens in the trial frame. Ask the patient to fix on an accommodative target like 6-9 or 6-12 optotype of the Snellen chart. The deviation is again measured after placing -2 diopter sphere lens in the trial frame. Here the phoria with additional minus lens is 2 prism diopter esophoria. After the examination we got the following values: phoria with additional lens 2 prism diopter esophoria, baseline phoria 8 prism diopter esophoria, power of additional minus lens is 2. The sign of esophoria is plus and for exophoria it is minus. Put these values in the given formula. The AC by A ratio by this method is 3:1. Using convex lenses for 33 cm at near, the subject with his proper refractive correction is asked to fix at an accommodative target at 33 cm and the deviation is measured. Here in this patient near deviation is 2 prism diopter exophoria. This gives our baseline phoria. Now add plus lens +1 or +2 or +3, any of them in front of eye binocularly. Here I am placing +2 diopter lens in the trial frame and ask the patient to fix on same accommodative target. The deviation is measured again with the patient fixing at the same target but through +2 diopter lens. Here the phoria with additional plus lens is 12 prism diopter esophoria. After the examination we got the following values: phoria with additional lens is 12 prism diopter esophoria, baseline phoria is 2 prism diopter exophoria, power of additional plus lens is 2. The sign of esophoria is plus and for exophoria it is minus. Put these values in the given formula. The AC by A ratio by this method is 7:1. Normal AC by A ratio. The normal AC by A ratio is about 3 to 5 prism diopters for 1 diopter of accommodation. The concept of AC by A ratio was first clearly defined by Fry, who later with Haynes introduced the abbreviation AC by A ratio. Indication of measurement of AC by A ratio. The AC by A ratio is useful to study in cases of accommodative esotropia to understand the different types and manage them differently. Exodeviations with simulated divergence axis exotropia to be differentiated from the true divergence axis exotropia. It helps in diagnosing and managing binocular vision anomalies. Measurement of the AC by A ratio is important in the diagnosis and treatment of the strabismus. The AC by A ratio can indicate the cause of strabismus and helps to guide the management. When AC by A ratio is high, hyperopic patients should be given full correction while myopic patients should be undercorrected. If AC by A ratio is low, undercorrect hyperopic patient and give myopic patient their full correction. That's all from this topic. Kindly subscribe the channel and press the bell icon for latest updates. Thank you for watching.